Matthew,
Power rule.
power rule, I'm gonna put right here. And I'm gonna make an example. So, power rule, I'm gonna write right here. So if I gave you something that looks like this, f of x equals x squared, Matthew, you would tell me the derivative is what?
2x.
2x, excellent. Okay? Ben, give me a rule.
The product rule.
Product rule, product rule, product rule I'm gonna write down here. And I'm gonna write, product rule here. And let's see, what did I have for an example? Right here, this is what I thought, f of x equals x squared e to the x. So its derivative, Ben, would be what?
X squared times e to the x plus 2x e to the x.
Perfect, excellent. All right, Owen,
Quotient rule.
quotient rule, and I'm gonna write that right here. And what did I pick as, oh, right here, quotient. And let's have, f of x be x squared over e to the x. So its derivative would be what?
2x e to the x
Okay,
minus
2x e to the x minus, excellent,
e to the x squared
yep,
over e to the x squared.
that's perfect. Okay, that's awesome. I'm gonna simplify that, okay? I can factor out e to the x,
Yeah.
and down here I'll have, or excuse me, I'll have 2x minus x squared over e to the x squared, right? And these will simplify, because this is e to the x times e to the x, correct?
Yeah.
To 2x minus x squared over e to the x. Are you okay with that? All right, very good. Colin, that's not one of our derivative rules or procedures. I can pick one for you. Constant. So I'm going to say my constant rule. F of x equals, I'm going to pick a constant, Colin. I'm going to send that constant to your mind. What number am I sending you?
3.
Correct, very good. What is its derivative?
1.
What?
Or nothing.
I didn't hear you.
It's nothing.
What number do we use to represent nothing?
1. And then 0.
I think, did you say 0?
Yes.
Yes. The derivative is always 0. Okay? Grace. I can pick one if you're not sure. Would you like me to pick one? Okay, it's what we call the constant. They have some weird names here. Multiple. That's why it's nice for me to give you constant multiple. And this is like f of x, what did I choose? 3x squared, its derivative is, Grace, what? 6x. Excellent.
I'm pretty sure that's just a power rule.
You just have you know what, I'm not gonna disagree with you. It's just kind of a special power rule. You're just taking the 2 times the 3 rather than the 2 times the 1. So are you correct? As
I mean,
usual,
basically-
yes.
Basically, technically, the power rule is just a constant multiple, if that's the case, because we're multiplying the exponent times
That multiple.
the coefficient, which in the power rule's case, as it's stated on there, unlike how we use it, is 1.
Correct, I would agree.
But we just all call it the power rule because it's easier, and because we just like it to call it that,
Yeah,
and because it uses the power rule.
right, plus I have to fill up space. Okay? Austin,
You just pick one?
what?
You just wanna pick one?
Yeah.
Sure.
That means difference, is that okay? Like I said, I got 5 hours of sleep, I'm a little lazy this morning. Alright, what did I pick? F of x equals x squared minus 3x plus 6. Its derivative, Austin, would be
2x minus 3.
minus 3, and that 6 becomes 0, correct? Because it's a constant. Pardon?
Oh, where should I put that on the unit part?
Oh, I forgot to write this up here. Some difference. Callan?
What about for sine, cosine?
Yeah, what do we call those?
I don't know.
Trig.
Trig is pretty, basically, as long as I have my notes here, I can remember the complex ones.
So there's 6 of them, right? Okay. So, f is equal to sine. F prime would be equal to,
Cosine.
perfect. F would be equal to cosine. The derivative would be,
Negative sine.
bingo, 2 for 2, and you said those so quickly. F equals tangent. F prime would equal, okay, anybody have that? Yep. Secant squared, is that what you said? Okay. F equals secant. F prime equals, do you know this one?
Cosecant.
No. Yes. Secant tangent. Wow. Usually people don't know these. You guys, most people got these down by now, these two, right? These other ones you're getting kind of used to yet?
Yeah,
Okay.
I remember them on my own for the first time. I've done it. I've beat.
Okay. Cotangent. Callan, you think you know this one?
Is it negative?
Negative what?
Cosecant squared?
Yeah, very good. Very good. And, which one am I missing? Cosecant here. Do you have that one? It's kind of like this. It's gonna be 2 of them, and it's gonna be negative, right, because it's a co-functions. Not sure? If cosecant x, cotangent x. Okay. You took a bunch of them, all right, just by saying the word trig. Okay? Audrey.
Implicit differentiation.
I didn't hear ya.
Implicit differentiation.
Oh, implicit differentiation goes over here. It's a big word. All right, and here's the one that I picked for that. Implicit differentiation. Right here. Y squared plus 2y equals x squared plus 2x. Okay, Audrey, you ready?
Divide
2y dy dx plus
it, 2 dy
2 dy dx equals
2x,
2x plus 2. What's my next step?
factor out dy dx.
Factor out dy dx. Oops, need a parenthesis here. 2y plus 2, would you agree?
Yep.
2x plus 2, correct?
Yes. And then divide out 2y plus 2 for both sides.
This is a 2. Which is 2x plus 2 over 2y plus 2, would you agree? Can I divide everything by 2 to make life a little bit simpler? So do you see where I get x plus 1 over y plus 1?
Yep.
I just factored out a 2 and divided it in my head. Is that okay with everybody? All right. Very good. Maria.
I'll let you pick one.
Okay, I'm gonna pick exponential. So here's exponential. Here's my example. F equals e to the x. Its derivative is, Maria? Oh, hey, you said that so nicely. Okay, I'm gonna give you another one since you're so good. 2 to the x. Everybody remembers this one. Everybody usually forgets this one. Did you remember?
Is it
Go ahead. ln of 2 times 2 to the x. So you know how you get e to the x here? You're gonna get that 2 to the x here. The only reason ln of e is 1. Okay, that's the only difference between those two. Okay, Jonah?
Log and natural log.
Log, or what we call, we'll call it log. Okay, or it's called logarithm. I got the room, I guess I should write it. Okay, so over here is where I'm gonna write log. So f equals the natural log of x, f prime equals
1 over x.
1 over x. Excellent. And then if I have, what's the other one I have here? Where are you? Okay. F equals log base 2 of x. What is its derivative?
Is it ln of 2 times 1 over x?
ln of 2 is on the bottom times x 1. All right, we're almost done.
okay? I did not remember the log of 2 thing.
Yeah, that's log base 2.
Could you explain how you get that one? Just real quick so I can remember it better.
Yeah, I can remember how I did that. Y equals log base 2 of x. Okay? That means 2 to the y equals x. okay? So if I take the derivative of this, I'll get the natural log of 2 times 2 to the y, right? Because I just did that with Maria, correct?
Wouldn't you give a,
Times dy dx. And over here I'll get 1, because the derivative of x is 1.
I see it now.
Okay, and so then when you divide by, get this by itself, you're gonna have 1 over the natural log of 2 times 2 to the y, but 2 to the y is x, and the natural log of 2 times x.
Okay,
Okay?
so I just forget basically how log basically you transfer it into your ln format.
Well, if I had y equals the ln of x, dy dx, this is equal log base e of x, correct? So I'd have 1 over the natural log of e times x. Well, what's the natural log of e? 1. Okay? I can give you this copy and you can look at it more.
Yeah, I'll
later if
take
you want.
that.
I'll put it aside and I'll give it to you later, okay?
Yeah, because I usually forget how the ln and log stuff works.
When I get stuck, I usually put it in this exponential form, and then I do implicit differentiation. Okay?
How does like the 2y there change to the x then?
So right here I had this,
Yep.
and so
Oh, yeah,
this is
yeah.
my base, this is my exponent, that's my answer, so then I just wrote it in exponential form.
Mhm.
And then what I did is, okay, how did I do this? Well, Maria said, hey, it's the ln of 2 times 2 to the y, but then you gotta take the derivative of y and get dy dx. The derivative of x is 1, and then I divided both sides and got this, and then I said, hey, this is the same as x, and so then this becomes this,
Okay. Yep. That makes
okay?
sense.
And so, when I forget, which I hate to say happens more often than it should, I'm really good at going from logs to exponents, and I'm good at implicit differentiation. So I lean on that. Does that kind of make sense?
Yeah.
And it all, and what's unfortunate for you guys is logs are still fairly new, exponential form is still fairly new, and
What they
and implicit differentiation is fairly new. But as we progress through the year, you'll get more and more comfortable with it.
So
I
what-
can already tell you're more comfortable with it
What do you
by
mean by
what
it's new?
stuff you're already telling me that you know.
What do you mean by it's new? What they invented to do math recently?
No, but what I'm saying is,
It's new to us.
I'm not any smarter than any of you in here. I'm just older and been doing math a lot longer and seen a lot more problems. So it's just an experience difference, not a aptitude difference. You understand what I mean? And so what my difficulty is every year is giving you quality experiences that last so you can remember in May. Does that kind of make sense? So we're back to here, correct? And we're to Tyler, am I right? So this is recent, this is the new stuff, correct? So what other thing could we put here that's new? Oh, inverse. Okay, we'll put that right here. And so let me, what can I say here? Let's say inverse. Let's say over here I have, what's a miserable thing? Y, let's make it f equals x to the 5th plus x, okay? Over here is f inverse. First of all, what's f and I gotta write this as a negative 1. What's F inverse of 2? How would you figure that out?
By finding when F is
You would take x to the 5th plus x, and it's gotta equal 2, correct? Now I made an easy one. What's that number? What can I put in for x that would make that 2? 1. Would everybody agree with that? So over here, x is equal to 1, so I got the point 1 comma 2, correct? Over here, this would equal what? 1. So what's the derivative of f inverse at 2 with respect to x? What would I have to do over here? I would have to find the what of f? The derivative of f, correct? And that's going to be what?
5x to the 4th
5x to the 4th
plus 1.
plus 1. And what am I going to put into here? 1. And when I put 1 into there, I get what number here? 6. So over here, the inverse at 2, its slope will be 1/6. Okay? That's a lot of work. Good job. All right. We're missing 2. Inverse trig. Inverse trig is here. So I'm going to do that on the back side. Inverse trig. This is just what we talked about yesterday and Friday, correct? So f equals the sine inverse of x. F prime is equal to 1 over something. Does it have a square root or not? Yes, it does. Okay, if it's the cosine inverse, are you happy to see that? Just that, but negative. F sine, cosine. Let's go tangent. Does it have a square root? No. What's on the bottom? Squared plus 1. Are you happy to see cotangent? You're gonna tell me just make that -1, right? Right? Slide up a little bit. We got 2 left. This one is weird, I think. Its derivative is 1 over what? And this is it's reversed here, isn't it? And then the cosecant you're happy to see, because once you get this one figured out, it's going to be what? And that's just what we learned, right? Those are the base ones.
Yep, and I'm not gonna remember the bottom two, so I'm gonna continue to use my notes for that.
Yeah, I would. I'm going to tell you the most popular one, the most popular two. The most popular trig inverse one is this, right here. Tangent inverse. You'll see it guaranteed. The second most popular is this. The other ones, and you guys understand, have I told you what you need to get for a 5? 60%. You know what you need for a 3? 30%. I know you don't believe me. Wait till we take the test. Practice test, okay? So somewhere between 30 to 60%. I think, what was it, 8 years ago, somebody got a perfect on it for the very first time in 25 years or something. And like, I don't know, 250,000 people, students take the test at the same time. So, and that's, yeah, same time. All right, same day. Back
One
side,
student got the entire thing right?
yeah,
My God.
yeah, I know. All right, Matthew, which one are we missing? You know?
The one where when we changed y to y, the derivative for y, I believe, was that implicit? Chain rule.
Chain rule. And here's my chain rule. F is equal to, and the reason I'm giving you this one is I gave it to you on assignment, and I said that you had to use your calculator. Does everybody remember that? Okay, well, maybe, probably not. I remember it, okay? And I wish Ella was here, because she texted me at home and said, how are we supposed to do this one? I said, you can't do it yet, because you don't know how to do it. You had to do it on your calculator. But, Matthew, do you know how to do this now?
Okay. 2 tests of skill. Let's see, one,
You have this, it's in this form. Correct? So what?
inverse of sine of x times e of x times e of x.
We got E of something. Does anybody know E of what?
Sin X.
E of sine of X. That's guaranteed to be there, right? That never leaves.
Okay, so I took a math, so I basically failed spectacularly.
No. It's a tough one. I think it's the toughest. Times the derivative of what now? The derivative of G, right? The derivative of,
Sin.
what is the derivative of sine? Negative, oh, you're right, cosine.
I see
screwed
what
up.
I did wrong now.
And so that's the chain rule. You end up taking a derivative times another derivative, okay? And you create these links, these chains.
I understand the chain rule. This one was just very tricky.
Yeah, it was. Now, can this ever be 0?
Yeah.
How?
It's a constant.
Okay? You have a number here, right? Okay, let's say I have this. Okay, so because sometimes E scares us. 3 doesn't ever scare you, does it? Okay? Can you put a number in here to make this 0? It's impossible. In fact, the graph looks like this. At 0, it's 1, right? And then it goes up like this. As this gets more and more negative, it just gets smaller, right?
But we have a coefficient.
But, oops. So this can't be 0, but can this be 0? Yeah. Okay, so that means, and wherever cosine is 0 is where this derivative will be 0, correct? Why do I say that? When I have a slope of 0, I have a horizontal tangent line, correct? Okay, that's gonna be important down the road, horizontal tangent lines. Okay, because that's where peaks and our valleys are at. Okay, here, so this must mean there are some places on this graph that has horizontal tangent lines because cosine makes it 0. If you understand that right now, that's really good. Okay. So that was it for the notes. Okay,
You have an
so it was
assignment?
kind of review. So you'll get a mixture of these kind of problems. You'll say, okay, which of these examples does it look like? Oh, don't give me that look.
What look?